Good morning, class. Come on in, take your seats. How was everybody's weekend? It's good to be back, right? All right. Well, now that everyone's settled, good. Today we are going to learn about Pythagorean theorem. Has anybody heard of it? No? Okay. It's okay. So we're going to start out by passing out these preparation for learning about Pythagorean theorem. So we're going to learn about Pythagoras really quick. If everybody will just take a piece of paper here and pass them back in your rows. Thank you. All right. We're going to take a seat here. Everyone have paper? Okay, so we're just going to read it out. And let's just answer these questions about Pythagoras, okay? So Pythagoras lived in the 500s BC and was one of the first Greek mathematical thinkers. He spent most of his life in the Greek colonies in Sicily and southern Italy. He had a group of followers who followed him around and taught other people what he had taught them. The Pythagoreans were known for their pure lives. So they didn't eat beans, for example, because they thought beans were not pure enough. They wore their hair long and they wore only simple clothing and went barefoot. Both men and women were Pythagoreans. Pythagoreans were interested in philosophy, but especially in music and mathematics. Two ways of making order out of chaos. Music is noise that makes sense, and mathematics is a set of rules for how the world works. Pythagoras himself is best known for proving that Pythagorean theorem was true. The Sumerians, 2,000 years earlier, already knew that it was generally true, and they used it in their measurements. But Pythagoras is said to have proved that it would always be true. We don't really know whether it was Pythagoras that proved it, because there is no evidence for it until the time of Euclid. But that is the tradition. While we call it Pythagorean theorem, it was also known by Indian, Greek, Chinese, and Babylonian mathematicians well before he lived. Isn't that interesting? All right, so we're going to answer question A. What do you know about Pythagoras? Sally, do you know? Okay, yes, he had long hair. Long hair, good job. Okay, anyone else? Okay, good. Yes, he did live a pure life. Okay, and what else? What else is in here? He proved that it will always be true. To always be true, yes. Okay, now let's just go ahead and go to question B. Who were Pythagoreans? What were they interested in? So we can go back to Sally's answer there. They had pure lives, yes. Okay, and they loved music. Good job, John. Music and math, yes. But there was one more thing they were interested in. Philosophy, yes. Good job. Anyone else? Okay. Who proved Pythagorean theorem? The Sumerians. Good job. Yes. But he proved that it would always be true, correct? So we can put his. Yes. Pythagoras. Good job. All right, so let's get into what really is Pythagorean theorem, okay? So set those aside. Let's take out our notebooks. Everyone have your notebooks? Clean paper, everyone. Okay, yes. Did you have a question? Okay. Okay, so let's identify what a Pythagorean theorem is and how we can see it illustrated, okay? So let's take our marker. Okay, so for Pythagorean theorem, it's going to be a right triangle, okay? So let's draw a right triangle. I think everyone knows how to do that. Okay, so let's do that. And we're going to go this way. And then right back down. Good job, everybody. Looks pretty good. Let's draw our right angle. Good job, Tim. Good job. And that's how we identify what a right triangle is, right? That's how we know it is a right triangle. Good. Okay, so now we're gonna identify the sides and all of our, label our right triangle, correct? That's how we know how to do the Pythagorean theorem. So let's label this right triangle first. So some things you're gonna need to know about the right triangle is you're gonna have to know the sides, okay? And we're gonna label those A and B, okay? All right, and then we're gonna have to know the hypotenuse, okay? And then we're gonna label that C, okay? So, our sides to the right triangle is gonna be our vertical and our horizontal. Okay, so we're gonna label this one A and our horizontal line B. Okay, and then our hypotenuse is gonna be our diagonal line that connects the whole triangle together, and it's also opposite from our right angle. Okay, so one thing or two things, you'll always know which one your hypotenuse is going to be because it is going to be opposite from your right angle. Another is your diagonal line is your longest line. Your hypotenuse is your longest line. Okay, so we're going to make a note over here. Longest line. All right, good job. Okay, so now that we got our right triangle identified, we can now look at our equation for the Pythagorean theorem. So let's write that down. So our Pythagorean theorem is, ready? A squared plus B squared equals C squared. Okay? Easy. And then we're going to break that down to solve it, okay? So we're going to take our A times A plus B times B equals C times C. Okay? And now, one thing with the Pythagorean theorem, in equations all, you always have a missing link, right? So, let's do a problem here. So let's draw our right triangle really quick. Awesome. Okay. So now let's say, let's let this side be 3 and let your other side be 4. Don't forget your right triangle. But now we have an X in that C spot, and X's mean they are missing, right? So we now have to solve for X. So let's do that. So let's remind ourselves what the equation to our problem is. Let's take a squared plus b squared equals c squared. Okay? Now let's fill in our numbers, our letters, okay? So now we have 3 squared plus 4 squared equals, we're missing that, right? So let's just leave that c squared, or x squared, okay? Because we don't know what that problem, or what that number is, okay? Now, if you need to use your calculators, they are recommended for you, or, you know, if you have them. But let's not use them right now, okay? So, 3 squared is, correct, 9 plus, good job, 4 squared is 16 equals x squared. Okay? So now we're going to add our numbers over here on this side. So we have x squared equals 25. Okay, so now what are we going to do? We have a letter over here that's not supposed to have a square root with it, right? So how do we solve for that? Good job all the way in the back. You do square each side to get rid of this square root, okay? Or this square. You square root each side. So we're going to take the square root of each side, and that eliminates our 2's, right? So now we just bring down our x. And what's the square root of 25? 5. So now our correct answer is x equals 5. Simple, right? So now I'm going to hand you an activity, and I'll keep this up here for reference. Let's take this up on the wall. Okay, we'll take that, and now we can have that just to look back on for our lesson. Okay, now let's bust out this paper. We'll pass everyone out a piece, thank you. Okay, and let's work together silently on solving these problems, and I'll walk around just in case if anybody needs any help, okay? Go. Yes, you can use your calculators if you need them. Yeah, good job. Yep, now find your x. Which one's your x? Find, yeah, your missing side. So we're just gonna put an x right there. Yeah, so just keep solving for that. Yeah, you just need one more step. Remember, what did we do here? Right, we got to square each side. Don't forget to square, because you're not done, okay? You got to get rid of that 2 of that square sign, or that square on top of your x, okay? Good, good job. All right, so pencils down. Let's work together really quick, okay? All right, so we're gonna find our x in problem 1. Good job. It was 35. Good job. That one was a big one. Yeah, I figured you would need your calculators for that one. B. How far up a wall will a 11-meter ladder reach if the foot of the ladder must be 4 from the base of the wall? So this one had new words, right? So we had to figure it all out. This one was a little tricky. Where did our 11 meters go? Good. Yes, it was our hypotenuse. That one was tricky because we haven't solved for that one, right? So we came from the other side. Correct. And it's the same thing. You just subtract it and move it to the other side. Alrighty, and then the 4 went on the bottom, correct. It was one of our sides. And then C was pretty simple. What was the answer? Good job. It was 6. Good job, everybody. Okay, so now we're going to move into our reflection. All right, our reflection steps. So if everyone could please pass your partners or your row a piece of paper. We're going to solve this really quietly, okay? We're going to work in groups to create Pythagorean theorem problems. The problems and answers must be whole numbers, okay? If you get a fraction or decimals, gotta scrap it and start over, okay? I know, it's tricky. It's tricky. So work in your row partners, okay? Your row groups, okay? And just create 3 problems. And then tomorrow, we'll come back and put these on the board and see how well our groups created problems together. Okay? And challenge us, okay? Challenge us. Make them really big numbers. It'll be a little hard, but put them 100 numbers in there. Okay? Make it a little difficult. Make it a little difficult for us. Let's try to do one together. Let me show you a big one that I'm just gonna create. Okay, so I'm gonna draw my right triangle first. Y'all can watch or y'all can keep doing your groups, but I want you to learn and to struggle through. Okay, so let me. One, 2, 3, 4, 5. Let's do 501. 500. Now, mine may not have a whole number, okay? But I'm trying to show you how big your right triangles could be, okay? And then we have 500 squared plus 500 squared equals x. X, don't forget to label, okay, is 501,001 equals squared. Oh no, what am I gonna do? And we have 7.7 or 707.8 equals x. So see, all right. Oh, and that's the bell. All right, everybody, have a good weekend.